Welcome to today's lesson, and today we'll be looking at travel graphs. Travel graphs is a line graph that gives a picture of how an object moves. The movement can be either on foot, bicycle, car. It can be any object that is moving. So we're going to look at a time graph, distance time graph. We're going to look at distance time graph and velocity time graph, even how to draw the distance time graph. How do you draw the velocity time graph? So we're going to look at distance time graph, how you can calculate the distance, how you can calculate the average speed, and how you can calculate the time. So now we shall see how distance, average, and time are related using the triangle. So if you check here, we have a triangle. We have a triangle that shows the relationship between distance, time, and speed. Distance, speed, and time. So distance is equals to speed multiplied by time. So if you want to find distance, you can use this formula here. Then we are saying if you're finding speed, you say speed is equals to distance divided by time taken. Then if you're finding total time or time taken, you're going to say total distance over time taken. Okay, so now how do you find distance? So when it comes to distance time graph, whenever you've been asked to find distance, they're actually simply asking you to find the area under that given shape. So if the given example here, we have a trapezium, we have a shape of a trapezium. So simply means that you have to find the area of a trapezium. If you find the area of a trapezium, then it means that you have actually found the distance covered in that shape, of that shape. Okay, so here we have the trapezium. So we all know how to find area of a trapezium, which is just half multiplied by a plus b times height. So simply this is the a, this is the height, and that's the b. So once you use this formula, it means you have actually found the distance traveled on this graph. So it might be an object traveling on foot, it can be a car, it can be train, it can be an aeroplane. So simply means that this distance covered is just the same as the area of a trapezium. Okay, so now let us see if you've been given a triangle, a right triangle. So simply remember we said if you're finding the distance, just find the area of that given shape. That's all. If you've been asked to find the distance, just find the area of that shape. So we've been given the triangle here. So what do you have to do? Or what you have to do is to find the area of the right angled triangle. So how do you find the area of a right angled triangle? So the formula is distance is equals to half multiplied by base multiplied by the height, which is the base, it's just this one, and the height, that one. So let us see if you've been given another shape, which is a rectangle. A rectangle is just L times B, meaning the length multiplied by the breadth. So if you find that area, it means that you've actually found the distance traveled by an object. If it's the square, it just means that you have to multiply L times L. So once you find the area of a square, it means you've actually traveled along the square. Okay, so we're going to talk about acceleration. What is acceleration? When someone say this guy is accelerating, what does it mean? Okay, so acceleration is just the rate of change of velocity with time, and it's given by the formula a is equals to v minus u over t, where a is actually acceleration given in AIC unit, which is meters per second squared. Then v is our final velocity. Then u is just the initial velocity, and t is the time given. So now what is retardation or deceleration? So this is just the negative of acceleration. When the car is accelerating, then we are saying it's a negative of accelerating, so meaning it has to go in the other direction. So for example, this part here, this is what we are calling retardation or deceleration. When the object is going to rest, it is called deceleration or retardation. Okay, so let us look at this example that we've been given. The graph below shows the speed, is v in meters per second, that's velocity, and the time t in seconds. So we've seen this object, we've seen this diagram where time is from 0 to 10 seconds to 40 seconds and 60 seconds. Then the final velocity is 15. So when we say initial velocity, it is when the object is just starting. So the initial velocity is 0. So then our final velocity is 15. Okay. So now let us see how we can actually solve the questions that are normally given of this kind. So the first question is find the acceleration in the first 10 seconds. Then the other question is, that's B, distance traveled in the first 40 seconds. Then C, acceleration between the 10th second and 4th second. Then D, find the retardation or deceleration. Then the last one is find the average speed for the whole journey. Okay, so the solutions for acceleration in the first 10. So if you are to check, we're only finding the acceleration from here up to there in the 10 seconds. So it's only from here up to there. So now what will be your initial, what will be your final velocity, and what will be your time taken. So your time taken will only be for 10 seconds. Then your initial will be 0 and your final velocity will be 15. So here the formula given, it's the acceleration is equals to final velocity minus initial over time. So we said our final velocity is 15, then our initial is 0 divided by 10, which is time taken, which is just 15 over 10, 3 over 2, and that is going to give us 1.5 meters per second. So meaning that should be your acceleration in the first 10 seconds. So now we're finding distance traveled in the first 40 seconds. So we're finding distance traveled in the first 40 seconds. So if we are to check, it's from here up to where 40 seconds is. So it is this shape. So if you are to check this shape actually it's a trapezium. So we can actually say this is a trapezium. So we know the formula for trapezium. How do we find the area of a trapezium? So once we find the area of a trapezium, it means that we found actually the distance traveled in the 40 seconds. So what is our formula for trapezium? It's half a plus b multiplied by h. So what is our a, what is our b, and what is our h? From the diagram, we noticed that our a, it was actually 30, then our base was 40, was actually 40. It was like that. Okay, then our base was 40, then our height was 15. So this is where it is coming from. So we have our height, which is 15, our A, which is 30, and our B, which is 40, which is just time taken. But how do we find this 30? Remember, there is a 10 that is this side. So you have to subtract 10 minus 40 for you just to get this distance that is here. So there is this 10 that is covered in the first 10. So now you subtract 40 minus 10 for you to get the 30 on top. So therefore we're going to have 30 here plus 40 multiplied by 15. So if you do the calculations, you're going to have 70 multiplied by 15, and the answer should be 525 meters. That's the area, meters per second. But remember, we're not finding the area. What are we finding? We are finding the distance covered. So we are saying the distance covered from here up to where the 40 second is only 525 meters. Okay, so now we have been asked to find the acceleration in the first 40. So the acceleration in the first 40, it's actually just constant, therefore it is equals to 0. Okay, so when there is no velocity, or velocity is not increasing, it just means that acceleration is going to be 0. Then retardation, that's D. We are saying retardation is just the opposite of acceleration. So all what you need to swap is the initial and the final velocity. So it will be initial minus final velocity, which is the initial. Now it will be 15. Remember, it's this part. So here our initial will be 15 this side. We are going to have 15, which will be our initial, our starting point. Remember, initial is always the starting point. Then the final velocity is your ending point. So our ending point will be 0. Therefore, our final velocity will be 0. So this is just going to be 15 over 20, and that will be 3 over 4 meters per second. That will be our retardation. So now let's check how do we find speed. Remember, in the first place we are talking about how to find speed. Speed is just equals to distance traveled over time taken. So now, have we been given the distance of the whole lot of the diagram, that of the shape that we've been given? No. So the thing is, we have to find the distance of the whole lot of the graph, which means you have to find distance of the whole lot of the graph. Okay, so now if we check, this is the whole lot of this is a trapezium. So for us to find the area of this, we have to use the formula for a trapezium. We have to use the formula for a trapezium, which is just distance is equals to half multiplied by a plus b multiplied by h. So we are saying once we find the area of this figure, it means that we found the distance of which we are looking for here, because we know that time here has been given, which is just 60. So now we're trying to find distance because we've not been given, but we know that we can find it by finding the area of a trapezium. So you're going to replace where this a, remember we said here it is 30, then the whole lot of it from 0 is going to be 60. So here our b is going to change to 60, then our height will still remain to be 15. So it is just going to be a plus b times that. So meaning we're going to say 30 plus 60 multiplied by 15, which is 90 multiplied by that. Okay, if you calculate this, you're going to find 675 meters. So meaning that should be the distance from here up to the destination here. Okay, so now that we have found distance, we have to go back to our formula and replace where there is distance and put 675 over the 60 here. Okay, so if you divide this, you're going to have 11 remainder 15 over 60, but then because you can still reduce this one, 15 there, 1 15 into 64, so it's going to be 11 1 over 4 meters per second. This is all what we had for you, so you can check this exercise and give it a try, see if you've understood. Make sure if you've not understood, just try to replay this video, try to understand every step that we've been given. So this is all what we had for today. In case you've not subscribed to this channel, make sure hit that subscribe button, notification bell, so that you don't miss any video that we post on this channel. Thank you for watching.